Hello guys, welcome back to the quantity surveying workshop and into another video. In today's video we are going to be treating the measurement for a simple staircase, and the kind of staircase we are going to be treating is the dog leg staircase, also known as the U-shaped staircase. It is that kind of staircase where you take your first flight up, then you rest on your landing, and then you take the second flight to the suspended floor. So you take your first flight, you land, and then take the second flight. So that is your dog leg staircase. So this is the kind of staircase we're talking about, going to be measuring. This is the dog leg staircase, where from here you take your first flight, then you rest on the landing, and then you take your second flight. So the first part of the staircase we are going to be treating is the unit of the staircase, which is the step. So the step is what makes the flight of the staircase. So the step comprises of the combination of your tread and your riser. So when you are climbing your staircase, you first climb the step, then you climb the second step, third step, depending on how many steps you have. So the horizontal part of the staircase, or of the step that you put your feet on, is called your tread. That is what this part of the staircase that you put your feet on is called the tread. And the part of the step that accommodates the tread, that gives support to the tread, is called your riser. So the riser is what gives elevation to the step to make you keep climbing up. Is called the riser. So we have our tread, we have our riser. The combination of the two gives you a step. So how many steps do we have in this building, in this staircase? We have 1, 2, 3, 4, 5, 6, and 7. The last one here is your landing. So we have a flight of 7 steps. So if we're having a flight of 7 steps, it means that we're going to be having 7 treads and 7 risers. Do you understand? Because I said this is 1, if we're calculating for the tread, or let's say the riser, this is 1, 2, 3, 4, 5, 6, 7. That's 7 riser. Then for the tread, 1, 2, 3, 4, 5, 6, 7. That's 7 treads. So the last one here would give you your landing. You don't calculate it as a riser and a tread. It's going to be your landing. The part of the staircase where maybe if the flight is too long, you can stay here and rest and then continue the second flight. Is called your landing. Now the part of the staircase, or let me just say the thickness of the staircase, is called your waist. That's the part of the staircase that makes the thickness. That's after the step. Let me use a ruler. If you cut this step like this, this thickness here, from here to here, is called your waist. It helps to give extra strength and support to the step. So it is on this waist that the step will be connected. So you need to understand that. So we've talked about our tread, our riser, the step, and we've now talked about the waist. We also talked about our landing. Now, after knowing all this, the next thing we're going to be treating about is the string. Now, this string is underneath the staircase. So that if you go to your staircase, just go underneath it. That part of the staircase under is called your string, or the surface of the staircase. So the part underneath it is called your string or the soffit. So after doing all this, there are now finishes to the staircase, where you will now treat the kind of finish you want to use on this staircase. There will be painting to the sides, whether it's painting or there will be tiles. So the kind of finishes you are going to be using for the staircase too will be measured. Also, in the finishes, we have what we call our newel posts. That's the first post of the staircase is called the newel posts. After the newel posts, the sub posts to give rigidity to this structure is called the balusters. So all the little ones, they are called the balusters. Now after you've gotten the balusters, then you will now go to the handrails. So the handrail is the part of the staircase that protects you from falling. An open staircase like this without this structure is very dangerous. Somebody can be running and before slips and falls. So this handrail protects you. At least you can hold it, especially when you are aged. When you are old, the handrail can serve as a support for you. It protects you from danger, from accidents. That is the purpose of this handrail. Now, after that, the distance between two threads is called your rise. So that means if this is my thread here, first thread, second thread, it means the distance from here to here would give me a rise. So they might say the rise is 150 mm. Hope you're getting the logic. Might be 200 mm depending on how high the staircase is. So the distance from two risers, if this is a riser, this is another riser, the distance from here to here would give me my going. So the distance from two risers will give me my going, but what I am stepping upon is called the thread. This is the thread. The distance from here to here is called the going. I hope you get the logic. Now there are some staircases that have some kind of design where there is a protrusion. There's a protrusion after each thread. So if from here to here is my thread, that protrusion is called a nosing. There are some staircases that I've seen some staircases like that, where after the thread there's a protrusion outside just for decoration and stuff like that. It's called your nosing. Now structurally, this staircase is usually reinforced. So while they are giving you your building design, it usually comes with a structural design for the reinforcement. So you are going to be having a structural design for the reinforcement used to construct this drawing. So this concrete is not just plain in-situ concrete, it is reinforced in-situ concrete. The reinforcement helps to give strength and stability to this staircase structure here, because without it, this staircase will fail. Now, I want you to also have in mind that when constructing the staircase, sometimes the staircase has what we call a base under here. So now let's just imagine that this flight is the flight for the ground floor. I know that before you get your staircase, there will be oversized concrete here. There will be oversized concrete. So now, before you get this oversized concrete, there should be like a base here for the staircase to serve let's say a foundation. But sometimes I've seen staircases that were not constructed with this base, maybe because it is a residential building where lots of loads are not usually lots of load are not usually exerted on the staircase, but in a public area or a public building where many people will be using the staircase at once, there is need for what? This foundation in the staircase. Now, this foundation in the staircase consists of reinforced concrete, and this reinforcement in the foundation base is what we call our starter bars. So it is from here that we'll have the reinforcement that will connect the other reinforcements for the staircase running like this. So it is from here that you get that reinforcement, connecting the reinforcement here. So to share more light on that, this is what I mean. If you look at this drawing, you can see that structurally I have given a structure of how the reinforcement bar would be laid. So if you can see under here, this part is the staircase foundation or base consisting of the starter bar. So this reinforcement here is your starter bar. It is going to connect the reinforcements going like this on top. That's the top reinforcement, while this one here is going to connect the bottom reinforcements. So now, talking of reinforcements, if you look at this drawing here, there are times maybe in school where they would just give you a plan and they'll tell you to calculate or to measure for the staircase. They wouldn't give you any reinforcement schedule or anything. Now, that is very difficult if you do not know how these reinforcements are being placed. So what you usually do when they don't give you a reinforcement schedule, you have to do multiple assumptions. So you know that your measurements might not be as accurate as possible because you're assuming, and the assumptions are going to be a lot. So it is important for them to give you a bar bending schedule, or a reinforcement schedule, or a reinforcement drawing. Like this is an example of a reinforcement drawing. Measuring for staircases are usually very easy, but where the issue now comes is when you are starting to calculate for your reinforcements, because there are lots of information you have to know before you can adequately measure for your reinforcements properly. So another information you have to know is your main bars and your distribution bars. So if you look at this drawing, we're assuming that the blue biro here is our reinforcement bars. So now these reinforcement bars are divided into two. That is your main bar and your distribution bar. So the bar that we have, that we've connoted here with a line. So you can see this line here. You can see the line going up. Then you can see the line here. These are your main bars. While the bars that we've shown as dotted here is called your distribution bars. So these bars are going to be laid in such a way, in something like this. So if this is your landing, then you have your staircase here, principal on the drawing here. So your distribution, your main bars are the bars going like this. These are your main bars. So if your view is like this, you know you're going to be seeing the bar as a line. That is how we got this drawing like this. Why the distribution bars are the ones that are going to be intersecting it like this. So you know that these distribution bars are like cylinders. So from this section or from this view, you're going to be seeing them as what? Dots. And that is why we have them like this. I hope you're getting the logic. So that's for the main bars and your what? Distribution bars. Now I'm trying to expatiate, because this knowledge alone can help you at least measure roughly the reinforcements. But when you have your reinforcement schedule or the drawing, it helps to strengthen the measurement of the reinforcement. Like, it gives more credibility to your measurement. So this is what we're going to be using as our reinforcement drawing. So through this, we are capable of measuring the reinforcements, all the detailed reinforcements in this drawing. So before I go here, let us start with how the process for measuring your staircase is supposed to be done. So when you are giving your staircase like this, like I said, this is a dog-leg staircase. Maybe you are going here, you sit on the landing, and then the second flight to the what? First floor. So now, what you need to do now is that after you've seen your plan, you go to your what? Section. So for example, if this is your section that is given to you, you want to measure for what? Your concrete work. No, you're going to measure for your concrete work, your reinforcement, your formwork, and then finishes. These are the 4 sections you're going to be measuring for in your staircase. First, we're going to be measuring our what? Concrete work. Now, to measure for your concrete work, I keep saying it, concrete takes the shape of your what? Form. That it takes the shape of your formwork. So what we're going to be doing now is, you're going to see that this staircase is not a regular shape. This is the idea I go about measuring my staircases that makes it very easy. This staircase design is not a regular shape. It is not a triangle, it is not a square, it is not a rectangle. But what we can do now is to divide this staircase into simpler what? Forms. So the first thing I'm going to be doing is I'm going to be dividing all the steps. Now you see why it's important for you to know the parts. So like I said before, the step is the combination of your what? Your tread and your what? Riser. So what I will do now is this. Like I said, this part here is your what? Landing. So we are not going to be cutting it from here. We are going to be cutting it from here down. So since I've cut this thing like this, now you can see we have what? A right angle triangle here. This is a right angle triangle, another right angle triangle, another right angle triangle. This is another one. This is another one. Now you've seen that we've made this part easy. We've already found a way to measure for our what? Step. By drawing this line, we've converted it into what? A triangle. Now the next thing we're going to be doing is we're going to be cutting what? The landing. Now when I cut the landing like this, you can see that this part is now what? A rectangle. So let me just draw something like this. This part now is now a what? Rectangle. Now there's something I forgot to tell you. Now if you look at this part of the landing, this part of the landing entered into the what? Wall. The reason why it is entering into the wall is so that it can have extra support. Sometimes after it protrudes into the wall, there's also a what beam at this side under, but not always. There will be a beam here to give support to this landing sitting on it, but sometimes the wall can do that function. So it will enter into the wall, so the wall will give the support to the landing. So now you see that we've gotten our what landing as what a rectangle. You know what is the area of a rectangle? Length times breadth. Now the last thing is our what waist. This is the shape of what a parallelogram. Now that we've divided this staircase into the important parts that we need, all we need to do now is to write it down. Now this is a plane shape. What we need is the area, but you know that concrete is not measured in meters square. It is measured as what meter cube. So we need one more parameter, which is what a length. So now we know that our area for the landing, which is the rectangle, is what length times what breadth. The area for a triangle, that's for the step, is what half base times what height. And the area for a parallelogram, which is what the waist, is equal to what base times what height. So once you've gotten this is your what area. But concrete is not measured in area, it is measured in what volume. So we're going to be multiplying it by what one more parameter. Let's say by another length to give you your what volume. So when you add everything together, that's the summation of this, will give you the what volume of concrete for the what staircase. I hope you understand what I have just done here. Please, if you do not understand, please draw me back in the comment section. I want to be seeing questions if you do not understand it, because this is very intricate. Now after doing this, you can now calculate for the what volume of concrete for the what base. This is a rectangle. Depending, the area of the rectangle is what the same thing, length times breadth. Then you multiply it by another parameter, which is what maybe another length. So this is just a basic introduction to how the measurement of the staircase is carried out for the concrete works. Now after measuring for the concrete works, the next thing you're going to be measuring for is the formwork. Now the formwork is very easy to measure. It's either you're measuring it in linear meter or you're measuring it in meter square, depending on where the formwork is going to be placed. Now, one thing about staircase is that you need to go to the site. Like, going to the site is very important, because when you go to the site, it makes things easy. Because quantity surveying is a profession that requires an imaginatory mind. So you have to have an image of what the drawing is telling you to do. That is why equipping yourself with site visits is a very good one, because staircase measurements can get you confused. But when you visit the sites regularly, you begin to understand how easy it actually is. So now going forward, the formwork. Now when you are constructing your staircase, if you look at this section, formwork, that's your wood, will be placed at the side of what? The stairs. So wood will be placed at this side here. It will also be placed at the other side. So the wood will be placed here and what? Here, in order for them to be able to construct both the step and the waist. So we're going to, this wood here will be measured in linear meter. That's the wood for this slanting side. That's for one flight. This flight, the wood here will be measured in linear meter, while the first flight, that's here, the wood will be measured in what? Linear meter. Now, when we get the measurement, we will book for this one. Now, the next one we're going to be measuring for is what? The soffit of the landing. Now, underneath here, wood is going to be placed under, because if there's nothing here to give support to the concrete, it's going to fall down. So wood is going to be placed underneath the soffit of what? The landing. So now all you need to know is what? You know that the length from here to here is 1,200 as given in the drawing. So all you need to do now is to less the waist, the thickness of the waist, to get from here to here, because it is here, that's this place, that the formwork will be placed under. So you need to find a means to derive what would be the length of the formwork. Now mind you, this formwork here for the soffit is measured in meters square. So since we've gotten the length that's from here to here, let's just make this parameter x. So the next parameter we're going to be looking for is y. What is y? Y will now be the distance from here to here, which is what? 2,500. So the distance from here, that's this dimension 2,500, will be our what? Y. So doing that, since you've gotten x and y, you've gotten your length and your what? Breadth for your what? Formwork. So that is that for the soffit of the landing. The next one we're going to be measuring for is the soffit of what? The string. That's this part. We have to put wood under to give support to the concrete that we're going to be pouring, to form the waist and to form what? The step. So this soffit is also measured in what? Meter square, not linear meter. Now, first things first, to find the length and breadth of our string, we need to find what is the measurement for this slope here, that's from here down to the end. And the only way we can do that is through Pythagoras theorem or any trigonometric ratio. So you are going to find for the hypotenuse. When you find the hypotenuse, that is this part here, then you are going to what? Multiply. Let's say the hypotenuse is our what? X. That's from here to here. It's our x. So we need to find the next parameter, which is our y. And then the y will now be how wide this staircase is. That's from here to here. So in this drawing, the width or the wideness of the staircase is given as what? 1,200. But in a case when you are not given the width, this is what you do. Since you know that the dimension from here to here is what? 2,500, and there's usually an opening here in the staircase. This opening is usually 50 to 100 mm. So all you are going to be doing is, let's just assume that it is 100 mm. So if from here to here is 100 mm, I'm going to remove that 100 mm from what? 2,500, and that will give me what? 2,400. So if I divide that 2,400 into 2 equal parts, that will give me what? 1,200 for both sides. So it means that there'll be 1,200 here, there'll be 1,200 here, making it what? 2,400. Then plus the 100 here will now make it what? 2,500. So that's one thing about measurement. You have to be conversant with your building plan and the dimensions. So it's not every time they will be spoon feeding you. So there are times you have to do serious arithmetics in order to get a particular dimension. Hope you are getting the logic. So now that we've gotten our parameter y, like I said, the formwork to the surface of the string is measured in what? Meter square. So we've gotten the hypotenuse as x, and we've gotten the what? Width of the staircase as what? Y. So x times y will give me what? The area for the formwork to cover this part. So we've covered here, we've covered the landing. So you know that the same thing we have here is the same thing we're going to be having here, because the number of steps here is equal to the number of steps here. Mind you, if the flight here is different from the flight here, you calculate it separately. So what I'm going to be doing now when measuring is this. First, I will count how many steps I have on the first flight, and then how many steps I have on the second flight to know if they are equal. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Second flight. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means that the first flight is equal to what? The second flight. Meaning what I have here for my formwork is the same thing as what I'm going to be having here for this formwork. It's simple mathematics. So once you now measure for your formwork for the first flight, just multiply it by what? 2. Straight to the point. Because here is equal to what? Here. So now doing that, plywood, like I said before, is going to cover this what? The side of the staircase. So now we need another plywood to what? Demarcate the what? Risers here. So after you've gotten plywood covering here, plywood inside is going to what? Demarcate the what? Risers. And we need to measure for that formwork, or for that wood that will give form to the risers. That part of the staircase, that's the riser, the formwork is measured in what? Linear meter. So all you need to do now is to get the width of what? Your staircase. So this part here, so for each riser there will be what? If a wood. So there will be wood here, wood here, wood here, wood here, wood here, wood here till the end. This wood will be attached to the wood for this sloping side here. So now all we need to do now to get for that formwork for the riser, just get the width of the staircase, which is what? 1,200 in this case, and then you book. Multiply it by the number of risers you have. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the number of risers you have. As for the thread, there will be nothing on the thread. There will be nothing covering the thread, because that is where you will now what? Do your tamping towards smoothing the staircase to make it flat. Everything I'm telling you is based off of knowledge from site work. That is why I keep saying it. If you're a quantity surveying workshopper, you have to go to the site. It is very important. Site work is very, very important. Okay, the last thing we're going to be measuring for the formwork is for this part here of the landing. So I told you that this part of the landing is going to protrude into the wall. So we have to cover this side here with formwork to protect the concrete from pouring outside. So all you need to do now is this. Just get the width of what you're landing, which is 2,500, because it is this area here that this landing is going to enter inside. So it's going to enter inside by what? 2500. So the formwork is going to be measured in 1 linear meter by what? 2500. So doing that, you measure for your what? Formwork. After measuring for your formwork, then we are going to be calculating for what? The reinforcement. Now we are going to be ending here, because as far as you have a reinforcement drawing or a reinforcement schedule, calculating for the reinforcements is very, very easy. So we've come to the end of today's video, guys. I hope you enjoyed watching it. Please don't forget to like, share and subscribe to this channel if you had adequate knowledge from this video. Secondly, if you are confused in any part, please draw me back in the comment sections. I need questions in the comment section. Thank you, and we'll see you in the next video.